All right, so this is an explanation of the double algebra day 5 homework on radicals with multiplying. All right, so take a minute, watch through this video to get an explanation of how the problems are done. If you don't understand one of them, make sure you pause, rewind, and watch it again. If you still don't understand, then make sure you ask someone around you to explain so that you can fix your work before you turn it in. All right, so looking at number 1. The first thing that I notice about number 1 is that it has this exponent of 2. Now remember, the exponent of 2 means we're multiplying it by itself, right? So that really means I'm going to take everything in the parentheses and multiply it by everything in the parentheses, since the parentheses are being raised to the exponent of 2. Now inside the parentheses is the square root of 5. So really what I'm doing is I'm multiplying the square root of 5 times itself, square root of 5. Since they're both inside the radical, we can go ahead and multiply them. 5 times 5 would be 25, and the square root of 25 is 5. Number 2 is really the same way, because again, there's this exponent of 2, which means I'm going to take everything that's in the parentheses and multiply it by itself. So in this case, that's 10 root 3 times 10 root 3. Remembering that we can only multiply outside numbers by outside numbers. So I'm going to do 10 times 10 first, which is 100. And then we can multiply the numbers in the radical by the other number in the radical. So we're going to do 3 times 3 and get the square root of 9. So remember, with multiplication, you multiply everything. Everything on the outside gets multiplied together, everything on the inside. And then we go back to the original stuff, which is simplifying. And in this case, the square root of 9 is 3. And we bring down the 100 out front. And remember, since there's no symbol there, we put a multiplication symbol, so our final answer is 300. Okay, number 3, again, it's everything in the parentheses being squared. So I'm going to take negative 3 root 5 and multiply it by itself, negative 3 root 5. Remembering that we multiply the outside numbers by each other, so negative 3 times negative 3 would give me a positive 9. And then we multiply the inside numbers by each other. So 5 times 5 would give me the square root of 25. And then we need to simplify. So the square root of 25 is 5. We still have our 9 out front. And then we multiply them together to get 45. Now these problems at the bottom really are a review from the previous days. So there's nothing to multiply here. I'm just trying to simplify it. So I need to find the largest perfect square that goes into 63 evenly. And hopefully we have our list of perfect squares at the top of each page so we have something to remind us of what to try. In this case, 9 is the biggest perfect square that goes into 63, and it goes into it 7 times. And the square root of 9 is 3. We can't take the square root of 7, so we just bring it down. Now, number 15 was meant to trick you, right? It has the square root of negative 16. But remember, we can't take the square root of a negative number. So this means no real solution. Or you could also say cannot simplify. Now remember, you actually can simplify this if you knew about imaginary numbers, which you will learn about when you get to Algebra 2. I will accept either answer. All right, number 6. Again, no multiplying involved here. We're just simplifying. So I need to find the largest perfect square that goes into 50 evenly, which is 25, and it goes into it twice. And then I need to bring my 6 down out front. So now we can take the square root of 25, which is 5. The 6 still gets brought down, and the square root of 2 as well. And remember, there's multiplication between these since there was no symbol. And 6 times 5 is 30, and the square root of 2 gets brought along. So that 30 square root of 2 is your final answer. All right, let's look at the back side. Now this is like the problems we were doing in class yesterday. So we should notice that in the first one, these are both inside the radical. Since both of them are inside the radical, we can go ahead and just multiply them together. So 14 times 14 is the square root of 196. And then I would type that in my calculator if I didn't have it written at the top to recognize that 196 is a perfect square. And the square root of 196 is 14. Okay, so let's look at number 8. This time there are numbers outside the radical, so I need to multiply my outside numbers first. So 2 times 5 will get me 10. And then, since we have two numbers inside the radical, we're going to multiply those together. 3 times 27 is 81. And this time, that number is actually a perfect square again, so I can go ahead and take the square root of 81, which is 9. Since the square root of 81 is 9, the square root is no longer there, and then we just multiply these together to get 90 as your final answer. Be careful not to take the square root of 9 again. A lot of people want to take the square root again to get 3, but remember, whatever number we have here should be able to be multiplied by itself to get 81. 3 times 3 is not 81. 9 times 9 is 81. So we stop once we take the square root once. All right, number 9. Same thing. There's 2 outside numbers, so we're going to go ahead and multiply those outside numbers together. 7 times 2 is 14. Then we're going to take the inside numbers and multiply those together. 30 times 6 is 180, so the square root of 180. We don't stop here because we need to make sure it's in simplest form. And 180 does have a perfect square that goes into it evenly. The largest perfect square is 36. So if you had used 9, it wasn't the largest, which is why you're not going to get the same answer as me. You need to use the largest perfect square. 36 goes into 180 5 times, and we bring that 14 down out front. Then we can take the square root of 36, which is 6, bring down our 14 out front and the square root of 5 in the back, and multiply these two together to get 84 square root of 5 as our final answer. All right, so let's look at number 10. So again, in number 10, there are 2 numbers on the outside, 4 and 2. So we're going to multiply 4 and 2 together to get 8. And then our 2 numbers inside the radical are 3 and 2. So 3 times 2 would get me square root of 6. Now I need to try and find a perfect square that divides into 6 evenly. There is no perfect square that divides into 6 evenly, so 8 square root of 6 is my final answer. Number 11. Again, there are 2 numbers outside the radical, so we're going to multiply those 2 together first. 2 times 3 would give me 6. Then we're going to take the numbers that are in the radical and multiply those together. So 5 times 5 is 25. Again, we try to simplify if we can, and since 25 is a perfect square, I can take the square root of 25 to get 5, bring down the 6 out front. Since there's nothing between them, it means multiplication, and 6 times 5 is 30. Now, number 12 to me is probably the most difficult one from this homework, and it's because you need to be careful about how this looks. I know that there's parentheses in between them, but remember, whenever we had parentheses next to parentheses before, it really just was a fancy way of saying multiplication. So really, this is just saying negative square root of 8 times negative 7 square root of 32. Now, the other tricky part here is the fact that there is this number on the outside here, but on the other one, there's not a number, there's just a negative sign. So remember, if there's not a number there, we can go ahead and put a 1, so that we're doing negative 1 times negative 7, which is positive 7. And then we can go ahead and multiply the radicals together. So 8 times 32 would be the square root of 256. Now, since this is such a big number, you should always make sure you type it in your calculator to see if it's a perfect square. So if I were to type this in, square root of 256, my calculator tells me that it's 16. So since it's a non-decimal, we can just leave it as 16 and then do 7 times 16, which is 112. All right, so again, if you have any of these problems that you didn't quite understand, you can always rewind to that problem and watch it again, or ask someone next to you to explain it to you, but make sure that you fix it. Make sure your first and last name is on it, and then pass it to the back of your row, and the last person in each row, please turn it in.